There we go. Okay. So when we are combining like terms, it says you can simplify an algebraic expression by combining like terms. This means that you combine the variable terms and then the constant terms. So again, just like we did up here, make sure you underline or circle the operation sign in front because it lets you know if it's positive or negative. Okay? So, what are some like terms I see here? What's my like variable terms? Negative 5x and very good. So how do I combine these? You just are adding or subtracting the coefficients depending on if it's a plus or a minus. So what's 7 minus 5? 2 then plus 4. So this becomes 6x. You good with that? Now let's look at our constants. I have a positive 3, a positive 8, and a minus 1. What's 3 plus 8?
11.
Minus 1. 10. And is it a positive or negative? So what needs to be in front of it? Plus 10. Are those two like terms? Why not? One has a variable, so one's a variable term, one's a constant. No variable. Good with that? Do we remember this from last year? Somewhat? Are we happy that I'm going over this? Yes, because some of us might not remember it, which is fine. That's why we're doing it. Okay, so let's look here. I'm going to zoom in. Okay, so let's look at number 1. Are those two like terms? Yeah, they both have an x, right? So what's 3 x's plus 6 more x's? 9 what? X. Very good. There's nothing else to do. We're down to one term. That's how you know that you're done simplifying. Okay, right here. Are these two like terms? Yes. What's 9a minus 10a? Negative 1a. Guys, do you ever have to have a coefficient of 1 actually written? No. So how else can I write this negative 1a? Just negative a. Will I count it wrong if you put negative 1a? No, it's not wrong. Negative 1a is the same as negative a. You're going to see me write it, though, without the understood coefficient of 1. Okay? Next one. Do I have like terms here? I have two terms that are like terms. Okay, what are my two like terms?
7 minus 5.
So what's 7 minus 5? 2 what? M. Is that just my answer? Why not? I still have that constant of negative 6, so drop down your minus 6. Can I now combine these two to make it negative 4m? No, they're not like terms. This is a variable term. This is a constant term. We good? Okay, next one. Do I have any like terms? Yes. Now this one we're kind of tricky because we have like constant terms. Do I have a like variable term? No. We always write our variable term before our constants though. So I'm going to drop down my negative 6w. We always want our constant term, we always want our variable term before our constant term. Okay? So then what are my two like constant terms? 9 plus 5. Notice when I'm circling my like terms, I'm including the operation sign in front. So what's 9 plus 5? 14. And it's a positive, so plus 14. Okay? I don't know why the screen's so bad. Is that a little better? That does look a little bit better, right? A little clearer? Okay. Do I have like terms on this next one? What are they? What kind of 9p? Negative, or a minus 9p. 7 minus 9. Negative 2. Anytime the larger number is negative, your answer is going to be negative. So negative 2p. Do I have like constant terms? Plus 5. What's negative 1 plus 5? Plus 4. Are those two like terms? No, so that's how I know we're done. Okay? Do we think we can do number 6 on our own? Do number 6 really quick on your own. Are we ready? Okay, what are my like terms? 5h plus 7h give you how many h's? 12 h's, very good. And then do I have other like terms? Negative 6 minus 8 is what?
Negative 14.
Negative 14. When they're the same operation sign, so they're both negative, add the numbers. So 6 plus 8 is 14, and since they're negative, it's negative 14. Good with that? Guys, also you can use your calculators to check your math work, okay? I'm okay with that. I give y'all calculators. This next one, we have two different variable terms. Are x terms and y terms like terms? They both have variables, though. They're not the same variable, okay? So just because I have two variable terms, if they're different variables, they're not considered like terms. Okay, so I have a 5x. Do I have another like term with my 5x?
Negative x.
Negative x. And if you want, here it wouldn't be a bad idea to put a 1 in front of that x. Okay, so I'm going to put a negative 1x. And then is there another like term? 3x, a plus 3x. So what's 5 minus 1? 4 plus 3, 7x. Okay. Do I have other like terms?
7y and 2y.
The 7y, a positive 7y, and a positive 2y. Positive 7 plus 2 is what?
9y.
Positive 9, so a plus 9y. Thumbs, how are we feeling? Good? Bad? You can give me honest opinions. I need to know honesty so I know kind of where we're at. Okay, I don't know y'all yet. We good? Ish? No one has a thumb down, so I'm happy about that. Okay, next one. I have A terms and B terms, so let's look at our A terms. I have 26A. Is there another A term?
Negative 4a.
Negative 4a. So it's 26 minus 4. 22. A is the variable. Okay, then what's next?
10b and 2b.
A positive 2b plus 10 more b's, which is what?
12b.
Positive 12 b's. Good? Okay, now we're going to look at some with exponents. We just said that like terms have the same variables, but that's not the only requirement. Like terms have to have the same variable and the same variable's exponent. So an x term and an x squared term are not like terms. They both have x's, but one's just an x and one's an x squared. So you have to have the same variable and variable's exponents to be like terms, okay? Notice up here it says, when combined, be sure not to change their exponents. Do not change the exponents. That's the biggest mistake. Okay, when you're adding and subtracting terms, the exponents on your variables will not change, just the coefficients. Okay, did y'all do any of this last year? We did no variables with exponents? Same exact thing, it's just you have to make sure the exponents are the same. Don't change the exponents, we're just changing the coefficients. Okay? So looking here, do they both have an x squared? Yeah, so are they like terms? Yes. I have 5x squares plus 7x squares. So what's 5 plus 7? 12. And what's my variable? X squared. Notice how I didn't change the exponent. When you're adding and subtracting like terms, just the coefficients changing, not the exponents. Okay? Next one, are these two like terms? Yeah, they both have a power of 5. So what's negative 15 plus 4? Negative 11. There you go. They're opposite signs, so you subtract the two. The larger number is negative, so your answer is negative. Negative 11. And then what's my variable? N to the 5th power. Don't change the exponent. Okay? So those were a little bit easier because we only had two terms. They both had the same variables with the same exponents. Okay, now we have 3 terms. Are all 3 of these terms like terms?
Yes.
Do they all have the same variable to the same power? C to the 3rd power, C to the 3rd power, C to the 3rd power. That means they're like terms. All 3 of these are like terms. So it's 8 minus 7. 1 plus 16. So it's 17. Do I change my variable or its exponent? Nope. C to the 3rd power. Okay? Next one. This one has a lot more stuff. Okay, so let's start with our k squared. I have an 8k squared. Do I have another k squared term? Very good. Negative 2k squared. These two middle terms have k's, but they don't have exponents of 2, so those are not like terms with my k squared terms. Okay? Do we see the difference? Okay? So what's 8k squared minus 2k squared? 6k squared. Okay? Now let's move on to our k's. I have a negative k, and I'm going to put a 1 there to help me. No, that's a negative 1k. Do I have another k term? Negative 5k. Very good. So what's negative 1 minus 5? Negative 6. What? K. We don't change the variable when we're adding and subtracting our terms. Okay? Then, I still have another term, right? I have my, what's this kind of term called? There's no variable? Constant term. Very good. There's no variable. Is there another constant term, or is that all by itself? It's all by itself. There's no like term. So I'm just going to drop down my plus 7. Notice the order I wrote that in. K to the 2nd power, K, then no K. Big exponent down to not even having a variable. That's the correct order. Okay? We good with that? Are y'all noticing how I'm underlining stuff, circling stuff, boxing stuff? Even if you're not color coding, this is a great thing to do. It's going to help you realize which terms you've already combined. Okay? Let's look at this next one. Ooh, this looks kind of tricky. I have a negative 4a squared b. That's all one term because it's all glued together. Terms are broken up by addition and subtraction signs. If I just look at that, is there a plus or minus anywhere in between the 4, the a, and the b? No, it's all glued together, meaning that's all one term. Okay, so I need to find another term that has an a squared b. Is there another term that has an a squared b? Very good, the plus 10a squared b. So it's negative 4 plus 10. And we keep our a squared b. And then I have my plus 7. Okay. Next one. Let's start with our first term. I have an x squared term. Is this an x squared term? Is this an x squared term? Is this an x squared term? Drop down your x squared. There's no like term to combine it with anything. Then let's go to our plus 2xy. Do I have another xy term?
Yeah.
Very good. Negative 7xy. So what's positive 2 minus 7? Negative 5xy. Okay. And then lastly, I have this plus 4y. Is there another, plus 4y squared. Is there another y squared term? No, so plus 4y squared. After you're done with these kind of a little bit more complicated or longer ones, make sure that once you've combined like terms that you don't have any more like terms. I have an x squared term, an xy term, and a y squared term. None of these are like terms. Okay, so we're done. Good? Are we saying that it's not that much harder if we have variables, or if our variables have exponents? We're essentially following the same exact process, right? So it's really not anything new as what it was last year. Okay, so let's start with our a squared. Is this an a squared term? No. No. That's a what? That's a b squared. That's not alike with an a squared, so I'm dropping down my a squared. Yes, they have the same exponent, but remember, to be like terms, you have to have the same variable and the variable's exponent. Okay? Then I have my plus 7ab. Do I have a like term with my ab? Negative 10ab. So what's 7 minus 10? Negative 3ab. And then last but not least, I have my plus b squared. Good? Do y'all think you can do 16 on your own? I think you can. Let's try it. Okay? And guys, I will tell you, at the beginning of the year, I am going a little bit slower. Like I said, I'm trying to get our brains clicked back on to math. Okay, so for some of y'all, if I am going too slow and you're working ahead, that's okay. Okay, we ready? Okay, so do I have a like term with my 4x squared? What is it? So it's 4 minus 3. 1x squared. Am I going to write the 1? I'm not, but if you wrote it, that's fine. X squared is the same as saying 1x squared. Okay? Then what term should go next? Your x terms or your constants? The x terms. So I'm going to skip that negative 7, and I'm going to go to my plus 2x. What's a like term with the x? The plus 8x. I have positive 2x's plus 8x's to give me plus 10x. Okay? Then I'm going to look at my what kind of terms? Constant terms, the ones that don't have variables. I have a negative 7 minus 6. What's negative 7 minus 6? Negative 13. How many of us got that right? Thumbs up. How many of us got it kind of right? Like at least one term of it right?
Doesn't matter if it's like in a certain order, but
it's not wrong if it's in a different order. This is the correct order. This is the order you should put it in, but if you wrote x squared minus 13 plus 10x, because that's kind of the order that the terms were originally in, it's not wrong, but I'm going to try to get y'all trained to write it big exponent down to your constant term. Okay? So you're not wrong. You got it right. If each individual term is correct, you're correct. Again, I'm going to try to get y'all x squared x constant. Okay? Okay, now let's go to application problems. Guys, these are exactly the same, just instead of it being written in a line, the sides of my different figures are labeled. It says find the perimeter. What does perimeter mean? The distance around. What do you do with it around to find the perimeter, though? What operation? Add them all together. Very good. So we're going to do the same thing of like underlining our like terms. I have a 2x term. Is there another x term? 3x. Is there another x term? X. And I'm going to put a 1 in front to help me know that that's a 1x. What's 2 x's plus 1x?
3x.
Plus 3 more? 6x. Okay, what's the only thing I've not underlined? My plus 1. Does it have a like term? Nope. Tack it on to the end. There's my perimeter. Again, perimeter means add all the sides. Okay? Next. Again, I'm going to start with my AB. Is there another AB term? No. For AB. Then let's go to our A terms. I have a 5A. Is there another A term? What kind of A? A negative or a minus. And I'm going to put a 1 there to help me know I'm subtracting 1. So what's 5 A's minus 1 A? 4 A's. And it's a positive. So plus 4 A's. The reason it's positive is 5 is my larger number and 5 is positive. Okay. Then I have my constants. I have a negative 1. And what else? Positive 17. So what's 17 minus 1? So plus 16. Are any of those like terms? These both have B's. This one doesn't have an A. So they're not like terms. Okay, they have to have the same variables. Okay. Oh no, this one, not all the sides are labeled. So am I just going to add these two sides? No. This is a rectangle because they're 4 right angles. So if this is y plus 2, what's this side? Y plus 2. If the top is 3y minus 5, the bottom. Got it? Okay, so let's look at our like terms. Let's start with y's. I have a y. I'm going to put a 1 there to help me know that's a 1y, 3y, 1y, and 3y. So I have 4 like terms here. What's 1 plus 3? 4 plus 1? 5 plus 3. So 8 what? Y. Very good. And then let's look at our constants. Plus 2 minus 5 plus 2 minus 5. Okay. So what's 2 minus 5? Negative 3. Negative 3 plus 2. Negative 1. Negative 1 minus 5 more. Negative 6. Are these like terms? Nope. Okay. Y'all try 20 on your own. Once you get an answer, guys, can you check with a friend? Yeah. See if you got the same thing as somebody by you. Because it's a k squared. K to the second, k to the second, k to the second, k to the second. All 4 of those are like terms. So now add the coefficients. I put a 1 in front of that one too. You did it on both those. 1, 1, 1. Yep.
Can I use the restroom?
Yeah, take the pass and sign out. almost. You're super organized. I want this. But then look here. 15. Okay, are we ready, guys? Let's see how we did. We have 4 k-squared terms. I have a 1k squared, a 1k squared, a 1k squared, and a 2k squared. 1, 1, 1, and then 2 gives you 5k squared. How many of us got 5k squared? Woohoo! Okay. Then we have plus 1k minus 9k plus 1k. So what's 1 minus 9? Negative 8 plus 1. Negative 7k. How many of us got minus 7k? Woohoo! And then plus 23 minus 17. What's 23 minus 17? A positive 6, so plus 6. Good? Do we have any questions? Our next page, which is the last page we're doing, we're not going to do all of it, is going to continue with combining like terms. We're just doing one additional thing. So if we're still a little iffy, we're going to keep combining like terms. Okay? How many of us have heard of the distributive property before, or done the distributive property? Some, maybe. Maybe you've done it, you just don't know what it's called. Okay, so the distributive property is if I have something glued to parentheses, I multiply, I distribute the thing that's outside, so A times B would be AB, but then I also have to distribute it to the second term in the parentheses as well. So A times C is AC. So I took that A and I put it with both terms inside the parentheses. I distributed it. That's what distribution is. Distribution is multiplying. Guys, make sure we're awake, okay? Make sure we're paying attention. Remember, math builds on itself. You want to have a good foundation, which is what we're doing right now. For the whole year, it's going to help you. Okay? This looks basically the same exact way. It's just now there's a minus. So A times B would be AB. And then A times negative C would be negative AC. I just put that A with both of the terms inside the parentheses. Okay? Again, when you're distributing, what operation are you doing? Multiplication. So let's maybe write a little note of that. Multiply when distributing. Okay? Now does this bring back memory for anybody that didn't think we did it, but we actually did do it last year? Anybody not say that they did it, but you actually have? No one? So y'all knew what distribution was if you've done it? Please, 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 from my experience, guys, draw your distribution arrows. The biggest mistake when we're distributing is we multiply that outside piece by the first term and we completely forget about the second term. That's completely wrong then, okay? If you draw the distribution arrows as you are multiplying, you are much more likely to get it correct. So let's look. I have a 7 and it's glued to my parentheses, which have an x and a plus 4 in it. So I'm going to draw my distribution arrow from the 7 to the x. 7 times x is just 7x. When you multiply a number by a variable, you just put the number next to the variable. Remember, numbers always go before variables. Coefficients go before the variable. I would never say x7, okay? Then we're going to also distribute that 7 to my positive 4. What's 7 times a positive 4? 28. A positive 28, so plus 28. So all I did was take that 7 on the outside and multiply it by both terms inside the parentheses. Okay, again, draw your distribution arrows as you are multiplying. Please, please, please. 2 times b is what?
2b.
Then 2 times 3 or negative 3? Negative 3. Be careful, that 3 has a minus in front of it. So 2 times negative 3 is? Negative 6, so minus 6. After we distribute, you should check to make sure you don't have like terms. Are these like terms? No. No, this is a b term and this is a constant term. They're not alike. They don't have the same variable. Okay? Next one. Let's distribute the negative 4. Negative 4 times y is?
Negative 4y.
And then negative 4 times a positive 3 is?
Negative 12.
Negative 12. How are we feeling about these, guys? Pretty good? Not too hard? Negative 5 times m.
Negative 5.
And then negative 5 times negative 2. What's a negative times a negative?
Positive.
A positive. 2 negatives make a positive. So negative 5 times negative 2 is a positive 10. Guys, I will tell you, this is not that hard of a concept. People normally catch on to this pretty quickly. We make very small errors of signs, okay, saying a negative times a negative is negative, okay, or just basic adding and subtracting with negative numbers. We struggle sometimes with negative numbers, okay. Normally, like I said, we understand the concept, but we make small math errors. Make sure you're taking your time and making sure that you're doing your computation part correctly. This one just has a negative out in front. That means all I'm doing is distributing a negative. It's really like a negative 1, okay? But a negative times y just makes it a negative y. A negative times a negative 9 is a positive 9, so a plus 9. Do we think we can do number 6 on our own? Do number 6 on your own. Some of us have already finished this whole unit. Yes, sir. Yes, take the pass and you can sign out. Writing it? I told you. It went well?
They're just like, oh, okay.
You can tear it down, sweetie, off the clipboard.
Oh.
Is this a 2.3
Mm-hmm. 2.3. I know, it's kind of messed up. Okay. 8 times 4 is? 32. And 8 times negative b? Negative 8b. Very good. Do we feel pretty confident right now? Can we skip the next row? I don't think we need to do all of these. Okay, we're going to skip the next row. If you want to do the next row, we can come back and do that, but I don't think us as a whole class needs to do it. Let's go to number 10. 3 times m, and then 3 times n. Are those like terms? They both have 3's. One's an n variable and one's an n variable. They are not like terms. Now we're distributing a variable. What's x times y? xy. When you're multiplying two variables together, you just put them next to each other. xy. And then x times 4. We would never say x4. Remember, coefficients go in front of variables. Good? Next, d times c is what? Correct, but what order do you think we probably should put it in? Alphabetical order. Is DC wrong? No. D times C is the same as C times D, but CD is the correct order. So we like to put things in alphabetical order. Okay? And then what's D times negative 4? Good? We're going to skip 13. Let's go to 14. Okay? Notice, this one's slightly different. Can anybody tell me why this one is different than the rest we've done so far? 3 what? What are they called? Starts with a T. Terms. There's 3 terms in the parenthesis. If there's 3 terms in the parenthesis, how many times are we distributing? 3 times. Before we've only distributed twice because there were only 2 terms. Now there's 3, we're distributing 3 times. 2 times x is 2x. 2 times negative y is negative 2y. And then 2 times positive 8 is positive 16. Are any of those like terms? No. We good? Okay. Next. This is kind of messed up looking. That's a 2.3. Okay, 2.3. 2.3 times 2y. You can use your calculator if you want, guys. What's 2.3 times 2? 4.6y. Then what's 2.3 times negative 5? 11.5. Oh, can use your calculator. Minus 11.5 what? And guys, you will learn that's my way I make a Z. I don't write super curly, so a lot of times my 2's look like Z's because I don't make a 2 curly. So this is how I make a Z look like a Z instead of a 2. Okay? And then we do have to distribute a third time because there were 3 terms in the parentheses. 2.3 times 1? 2.3, so plus 2.3. Okay, do we think we can do number 16 on our own?
Yep.
That's a 0.2. Okay, do 16 on your own, and that's a 0.2. You're good. Guys, the batteries are already dying because they're last year's batteries. If your calculator is not turning on, let me know. Yes. Yes. Take the pass and make sure you use the yellow bathroom. Remember, you can pull the clipboard down. It is on a Ziploc, or on a Velcro. Are we done? Okay, so we're going to distribute our 0.2. What's 0.2 times 8x? 1.6x. And then what is 0.2 times negative 4? Very good. Good with that? So that's distributing our decimals. Now we're going to distribute our fractions. In our math review warm-up, we did adding fractions. How do you multiply fractions? There's different rules for multiplying. When you're multiplying fractions, you multiply the two numerators together and the two denominators together. They do not have to have a common denominator, like when you add and subtract. So I distribute my 1/6 to my 3/5. 1 times 3 is? 6 times 5 is? 30. And we have an x. Okay? When you have a whole number, what's the denominator? 1. So I'm going to put my 18 over 1 to help me. So 1 times 18 is? And 6 times 1 is? Okay, let's simplify this though. When you have fractions, a lot of times you can simplify. 3 over 30, what can that become?
10. 1
over 10. So this is really 1/10 x. And then what's 18 over 6? 3. Simplify, simplify, simplify. Okay, we good with our distributing of our fraction? Okay, now let's distribute a negative fraction. Same process. A negative 1 times 4 is what?
Negative 4.
8 times 5 is?
4.
And it's an x. Put your 24 over 1. What's negative 1 times negative 24?
Positive 1.
Positive 24. And 1 times 8? 8. Are we okay with how I'm doing that? The numerator is multiplied together, the denominator is multiplied together. Now let's simplify. What's negative 4 over 40? 1 over 10. X. And then 24 over 8? 3. Good? Okay, sometimes you're going to have to distribute and then simplify. You're going to distribute to get rid of the parentheses, and then you're going to have like terms that you're going to have to combine. Okay? How do you know you need to distribute? There's something glued to the parentheses. Okay? So, what is 8 times 2x? What is 8 times negative 3? Am I going to distribute the 8 to the negative 6x? No, it's not in the parentheses, so I'm just going to drop down my minus 6x. Okay, so I got rid of my parentheses by distributing. Good job. Now do I have any like terms that I can add? Yes! Which ones?
16x and negative 6.
There we go. What's 16 minus 6? 10x minus 24. Good? So this is putting together what we just did with what we did at the beginning part of the notes. We good? Okay. What do I need to do on number 20? Do I have parentheses? When I see parentheses, that almost always means I need to distribute. When you're distributing, what operation do you do? Multiplication. What's 9 times 2k? What's 9 times negative 4? Good job, negative 36. Do I need to distribute again? Yes, because I have another set of parentheses. That's a negative 2. So what's negative 2 times 7k?
Negative 4k.
And then what is negative 2 times negative 12?
24.
Positive, so plus 24. Now do I have like terms? 18k minus 14k is what?
4K.
Negative 36 plus 24 is what? Negative 12. They're different signs, so you subtract them. The larger number, which is 36, is negative, so it's a negative 12. How are we feeling about these? Okay still? It's a longer process, right? But it's exactly what we've done at the beginning part of the notes and the middle part of the notes, just putting it together. Okay? This next one, these are the ones that we struggle with the most. Are we distributing the 10?
No.
Is the 10 glued to the parentheses? No. What's directly in front of the parentheses?
Negative.
Just a negative. So I'm dropping my 10 down. The 10 is not what you're distributing. The 10 is not glued to the parentheses. There's a minus in between. So what's a negative times y? And then a negative times a negative 6. Negative, negative? Positive 6. Am I distributing the negative to that negative y? No, because that negative y is not in the parentheses, so just drop down the negative y. Good? Do I have like terms? Which ones? Let's start with our variables first.
Negative Y.
Negative y, they're both negative 1y. So what does that become? Negative 2y. Then I have my constants. What are my constants that are like terms? 10 plus 6 is? So plus 16. Are those like terms?
No.
We're done. Good? We're not going to do the last row, so we have one more. Do we think we can do this last one on our own? 22, do we think we can do 22 on our own? I think you can. Try it. Use a pencil right now if you're not 100% confident, so in case you do make a mistake, you can fix it, okay? Why did it go away?
Plus 30W.
Okay, let's see, guys. The 6 is not attached to the parentheses, so I'm just dropping the 6 down. The 8 is glued to the parentheses, so I'm going to distribute my positive 8. So I get plus 32W, and then minus 56. Then I'm going to distribute my negative to get negative 2W, and a minus 1. Those are like terms, so I have 30W. And then these are my like terms that are my constants. 6 minus 56 is negative 50, minus 1 more is negative 51.
Wait, why did you put 30?
32 minus 2. Okay? How'd we do? Close-ish? Okay? Okay. That's it for notes for today. Your homework is on Delta Math. You can use your phone or you can go get a Chromebook if you would rather use a computer. Okay? Your homework is on Delta Math. So we are going to get started. You still have 20 minutes. Like I said.